Hello, statistics student. This video is for chapter 1.1 part 2. We are going to go over some examples for the terms that we have introduced. So that we have introduced 6 terms: population, the target group that we want to study. If possible, we'll do a census and collect all the data from it, but usually we don't. Sample is a subset of the larger population. Sometimes we're just happy with the sample. Okay. At other times, if we are doing inferential statistics, we would use the sample to do some projection on what the population would be. After you have data, a lot of time we'll calculate some numerical characteristics. That numerical number, like the average or percent of something, is called a parameter. And if you are using a sample to calculate average or percent or whatever that you want to calculate, like it could be median, it could be maximum, it could be range, so long as it's a numerical characteristic of the data that you have. But if the data is a sample, it's a statistic. So when you see the term statistics, it could be the branch of the study that we are doing, like this is statistic class, or it could be the number that you calculate from a sample. Okay, so that's the fourth. And the fifth one is variable, the name of the data that you are collecting. Okay, so you have a group of students that you want to survey. What are you going to ask them? So the name of the name of the value, like what characteristic is it? Very often you collect multiple variables from them. Okay, 6 would be data. Okay, the actual values of the variable. Okay, so first example 1. 37 students are randomly selected to find a proportion. So remember, proportion is percentage of something. Proportion of what? Who prefer a synchronous mode of teaching? What is the population and what is the sample? So you find those students who prefer asynchronous teaching, but um, you didn't ask everyone. You randomly selected some. So whenever you have to go through selection, this must be a sample, right? And this sample must be selected from the target group that you want to. So the target group is the population. I would say you're selecting from what? It must be from all students. Now, we do not know if it's all students of a college or all students in the world or all students in the US, but in general, it will be all students, whatever that makes sense. So what is the sample? The sample is the 37 randomly selected. So you can actually collect data from them. Of the 37 student survey, 14% prefer asynchronous teaching. So after you count them, it turns out that 14% like asynchronous teaching. So this it should not be 37%. It should be the 14%, right? I'm going to update the notes. So this 14%, is it a parameter or statistics? I calculate this from sample, right? So if anything that I calculate from a sample, it is not for all of them, for all the students. So it is a statistics because it's from a sample. C, the average income for all residents in the city is 34,000. So notice that it is all residents. So this must be whatever that you want to find out. So, and it is all of them. So some case you can actually find out all the data from your target population. So this must be a parameter. Why? Because it is from a population. You were able to get all the data that you want to. Okay. D, example of 45 college graduate survey and the average income is 35,000. So so look at sample. You calculate something from the sample. So so this average income is, the data itself would be like someone would, have income 30,000 only, some would have 55,000, but after you average all the data, you get these 34,000 data. This is the average of the 45 data that you collect, and it's from a sample. So this number is a statistics because it's from a sample, right? You calculate it from a sample. It is not the actual data. The actual data are being summarized into it. So the second thing we want to talk about is mixing them together. We have sample, population, statistics, and parameter, and maybe we can talk about what are the data that they're collecting and what are the variables. A study was conducted at a local college to analyze average GPA of students who graduated last year. So you want to find out the average GPA of all students. So I suppose it is all students. So that would be your target group. You want to know all the GPA, average cumulative GPA of all the students. So presumably you can get it from the registry if they give it to you, but obviously sometimes it's hard to get that. So you only survey 40 randomly selected group of students who graduated last year, so match the term. So the group of 40 students being surveyed, so this is the sample, right? You just you select from the group from the college. And then B, college registry actually published that average cumulative GPA of all students. So they actually do not need your study. They actually publish it that last year graduating students average GPA is 3.1. So this number is a parameter because for a registrar, they have all the data value and it's from a population, right? So from a population, so this must be a parameter. All students graduate, that is the population. So this is the population. So we have population, we have sample, we have parameter, so this must be a statistic. Why? Because it's a number, is an average calculated from a sample, so this is a statistic. And you can see that the statistics is a little different from the parameter, from the 40 students that you had, that their average GPA was 3.32, but the real one from all the students is 3.1. What are the variables and data? What are they collecting? What are the name of the data they're collecting? I would say the variable name is GPA, right? So if you have the 40 student, you ask them, what do you ask them? You ask, oh, what is your GPA? And what is data? Data are the list of the GPA values, right? GPA values, such as 3.1, 4.0, 2.5, dot, dot, dot. So the value itself is called data. The name of the data that you're collecting is called variable. Okay. 2, a study on car safety performed. A sample of 75 cars with dummies on the front seats were crashed into a wall at a speed of 35 miles per hour. So you have 75 cars that you're actually collecting data on, and each cars would crash into a wall. We don't know the proportion of dummies in the driver's seats that would have had head injuries. So we want to see if there is yes or no. If the dummy had head injury, if they have been actual drivers. For each car crash, the head injuries condition, yes or no. We look at the dummies to see if there's head injuries condition, and you record it. So that is your data. So what do you want? What are the terms? So we need to classify sample, population, statistics, and parameters with the description. So look at this description, all the cars. So in general, we want to look at all the cars. So that is our population, right? But you can only study 75 cars. So what is the 75? Oh, here, 75 car in the sample is the sample. And of those 75 cars, you actually can calculate what is the percent of the 75 cars that had injuries. So that would be a statistics because you actually can look at it. You collect them, you record it, you calculate the percentage But the percentage of all cars with head injuries, we actually don't know. But we know that this number, if we can calculate, is called a parameter. And if we don't, we would use the statistics to predict this parameter. So what data value are we collecting? So I know the value, I know the data value, right? The data values are yes, no, head injury, head injury, head injury. Oh, this car has no, etc. But what is the number? Head injury or not, right? Head injury conditions, I would say injury condition, yes or no. So that is the name of the data. We call it variable. The data itself is the values. Okay, so that is some examples that we use to practice knowing the 6 terms. Basically, population, parameter, statistics, sample, variable, and data. The last term that I want to add is related to probability, and there's a term called significant. Significant. Now, significant is an English word that means very important, but significant is related to if we describe something as significant, we actually just in statistics that means that this outcome, this event that I see has a very low chance of occurring. Low chance of happening is significant. Something that you are surprised. Why are you surprised? Because you generally know what is supposed to happen. Sometimes things don't always happen in a certain way, like the sun always rise from the east. We know that. But if there is some deviation, we will be surprised. Okay. So let's look at something that is, changes every time we do something, but we kind of know what is the acceptable range that is supposed to happen. And if something really rare happen, we will be very surprised. So the example one is half of the newborn are boys and half are girls. So if you look at hospital birth, suppose you don't know the mom, you don't know anything about the scan or whatever, so the chance that the baby is a boy or girl is just half and half, right? And one day 12 births are being conducted in the hospital, and you see 10 boys. So is this significant? That would be very, very deviate from the normal one. You're supposed to have the common ones are what? 6 and 6, right? 6 boy, 6 girl, maybe 7 boy, 5 girls is still acceptable. I don't know about 8 and 4, that is questionable, but 10 boy and only 2 girl, that deviate from this a lot, right? So this is very surprising. So it can happen, but it is very surprising. So we'll say this result is significant. This must be caused by something. The second one is you throw a dice. It's a fixed 6-face dice, so dice with dots on them, 1 and 2, those case. So you every face has one chance because it's a fair one. 1/6 chance of happening. If you throw 10 times, so at most you would have 1 or 2 ones, right? 1 or 2. So it comes up 2 times. Is it significant? You would say no, because it is expected. It is not unusual. It is not rare. It is not surprised that you have only 2, 1. If all of the 10 times that you throw it, 1 comes up 10 times, that is significant. But this is not significant. So in statistics, if a statistician talk about significant, you know that must be very surprised. Okay, so the last things that we want to talk about is percentage calculation and some percentage review, and also something about sample what is a good sample. Okay, so that would be part 3.